Hello, welcome. Time to get started, because I have slightly more slides than we have minutes. My name is Austin Witt, a senior software engineer from HomeAway.com, and I'm going to talk to you today about how to unit test your pipeline code. Because if you've got pipeline as code, you ought to have tests for that code, right? First, what are unit tests? I'm not going to read all this. Not every unit test will have these properties, but in general, unit tests ought to be repeatable, consistent, fast, only check one unit of functionality, and they ought to be implementation agnostic, meaning you can change the way you get the right answer, and the test won't break. The test should only be looking at the output of things. And that's nothing new, hopefully. There's a couple words we're going to use in the context of talking about unit testing pipeline code that I want to make sure we're clear on. A mock is a fake object that implements the interface of a real object, but just does nothing, returns nothing. Or actually, it would record any attempts to interact with it so that you, the test author, could then make assertions about what should have happened or check what did actually happen. And stubbing is when you need to specify some not-nothing behavior for a particular interaction with a mock. Maybe your code under test has some control flow, and it interacts with a mock object, and simply doing nothing causes an error. You may need to put some real behavior in there in order to explore every branch of your code that you're trying to test. All right, so hey, there's this thing called Spock that can unit test Groovy code. It's pretty cool. It's open source. It's fairly industry standard. It's at spockframework.org. I got a picture there of what a Spock test suite might look like and what its output might look like when a test fails. Why do we care about Spock? Because we want to unit test pipeline code, and pipeline code is just a domain-specific language on top of Groovy. So if we're trying to find a way to unit test pipeline code, something that can unit test Groovy code might be a good place to start. There's three kinds of pipeline code I'm going to talk about here today. There's the classic simple Jenkinsfile, your delivery pipeline. There's helper scripts that you might break out of your Jenkinsfile for simplicity. And then there are pipeline shared libraries, where you start to scale up the centralization and shareability of your pipeline code. So if you want to follow along, or if you think you might leave early, get out your laptop or a cell phone and record this slide. If you want to follow along, go to github.com, find the HomeAway organization, and clone the Jenkins Spock repository. If you don't want to follow along, but you think you might leave early, grab a photo of this slide. You've got the link to everything you need to do the tests, and a link to these slides in the bottom, so you can finish the presentation at your own pace later on. So here we go. All right, first let's write some unit tests for a Jenkins file. Look on the left here in the black. Here is a super basic example project. If you are following along, this is the whole-pipeline folder in the examples repository. It's a simple Python web application that says hello world and the number of times it said that. And there's a Docker file that puts the application inside a Docker image so that when you run that container, you get your web application. This is the Jenkins file. At the top, I have, I don't know, which one of these should I gesture at? At the top, I have collapsed the deploy method. We'll talk about that later. Let's look for now at the rest of the pipeline. We start off with a checkout stage where we check out the source code. Then there is a build stage that's just Docker build, a shell step Docker build for this application. Then when we're running tests, we are going to try to use the unit test Python module to find the test that we wrote for our Python web app. And if those tests fail, we're going to send a notification to Slack using the Jenkins Slack plugin. Now, if the tests pass, we go on down to the bottom where we're going to try to push, we're going to try to push the Docker image up to somewhere. And if once that's done, we can then try to deploy our application to the test environment using our deploy function that we have up top. And if that succeeds, then if we're on the master branch, we want to go ahead and push our application right out to production. So that's the Jenkins file for this simple sample project. So there's three behaviors that we're going to write unit tests for. We want to make sure that when the application tests fail, Slack gets notified. We want to test that non-master branches get deployed to the test environment, make sure that our CD is flowing, and we want to check that only the master branch gets deployed to the production environment. Writing that test well actually will take far more lines of code than will fit on the slides, so when we get there, we're going to hand wave it and write a much less capable test, but pretend with me. So this is the sum total of our first unit test for this Jenkins file. And we're going to go through what's going on in here. This is a slide, not an actual IDE, so I cannot zoom in. Hopefully it's visible enough. If not, github.com/HomeAway/Jenkins-Spock, clone it, and you can open it up on your own IDE. So the first thing that's going on here is setting up the test. So when you write a Spock test suite, you create a Groovy class that extends specification. If you want to unit test pipeline code, you create a Groovy class and extend the Jenkins pipeline specification that we have written. When you do this, you get several things. You get a couple handy methods inherited that are useful for orchestrating tests of Jenkins pipeline code, and you get every Jenkins pipeline step, symbol, and variable that exists set up as a Spock mock object ready for you to stub behaviors and make assertions about what did or did not happen to it. Next, as is common in a lot of unit testing frameworks, you can have a method to run setup before the entire test suite, setup before each method, in addition to doing setup in each actual test method. Here, the setup function method for this suite is going to, well, it's going to load a pipeline script for test. It's going to load our Jenkins file and assign that to Jenkinsfile. Pretty simple and intuitive, I hope. It loads it as a Groovy script, capital S script, which means all the things that you can do to Groovy scripts, which pipeline scripts are, you can do to them in your unit test. So here is our first unit test. It is a Spock convention to give your tests nice string names that are their assertion. So we're going to test that Slack is notified when tests fail. And there's several different ways to construct Spock unit tests. I'm not going to get into them too much because it's just stock Spock behavior. If you go to Spock's documentation, you'll find it all written up. We're going to be using the when-then construction today, which is for testing the side effects of things. So first, we're going to, I don't know, it's easiest for me to gesture the laser pointer at the one over there, so I'm going to do that from now on. So the first thing that we're doing in setup, we're going to get the pipeline mock for the SH step. And it is the Spock construction of these two arrows over on the right there. This means when this mock object is called with this argument, then do this behavior instead of doing nothing. So if you can recall our Jenkins file, we used the SH pipeline step with that input to kick off the tests of our application. So this is us saying, when you are running our Jenkins file during this test, and you try to run the application tests, throw that exception. So we have set up a fake test failure. Now, when we run our Jenkins file, still pretty intuitive, then we expect that one time, that is an asterisk, the pipeline mock for Slack send, that's the step that sends a message to Slack, should have been called with that. So that's an underscore, which is the Spock idiom for match any argument, don't care what it is. AsMap is Groovy type hinting. It's not useful to us here. It just helps us remember later on if we wanted to flesh this test out that, oh yeah, we're passing a map in. So we set up a fake test failure when we try to run our unit tests, our application tests, throw that exception. When we run our Jenkins file, we then expect that Slack should have been sent a message. We're ready to run this. How are we going to run it? We had a Python application with a Docker file. How are we going to run Groovy code? We're going to use Maven. Yes, Maven. For several reasons. Primarily, Jenkins' components, Jenkins core and its plugins, are all distributed as Maven artifacts. And so is this test library. And that becomes really important and awesome for a reason that we'll see a few slides later on. Let's get there. So to run Spock with Maven, you got to run Groovy with Maven. The gmaven plus plugin is how I'd recommend you do that. I know that works with this library, so this is the XML on the left that you would add for the plugin to get Spock to compile your Groovy tests that we just wrote, so that Maven will be able to run them with whatever you've got Maven running your tests. Probably the Surefire Maven plugin, but as you can see, they are added as test sources, so if you're using something else, it's fine, Maven will be able to work with them. We also have to touch a much less common configuration block over here on the right, the test sources. Because our Jenkins file, we're not compiling that. That's not source code, that's a script that we're going to load during the test. Where are we going to load it from? We're going to load it from the class path, so we have to say that it needs to be a resource on the class path. And ignore source test resources for now. We'll talk about that later when we see why. So with that done, we're ready to run the test, and we will get that error message with this test code if we were doing this in order. Illegal state exception. There's no pipeline step mock for SH, for the SH step. Didn't we just get pipeline mock SH in our test code? What's going on? Well, I also said every pipeline step, variable, and symbol that exists will be mocked. What is that set of things that exist? How can anybody know that? It's not possible. You might, in your company, have an internal step that exists nowhere else in the world. This library couldn't possibly come with knowledge of that. So it's got to learn about the steps that exist somewhere. What steps exist? Well, all pipeline steps come from jars. Those jars are all from Maven dependencies, so only the pipeline steps whose jars are dependencies will actually end up getting mocked. So what plugin does the SH pipeline step come from? It comes from that one. Add that as a dependency to our POM. Now it will automatically be set up as a mock that we can use. And this is the third reason for Maven that I mentioned. As a bonus, following this pattern, when we're done, our POM will contain an explicit list of every Jenkins plugin that needs to be installed on a Jenkins master in order for the pipeline to run. Previously, you might have a Jenkins file in a project, connect that to a Jenkins master, and right away get oh, that step doesn't exist. Maybe it's the send pretty Slack message step. Now you've got to figure out where that came from. Good luck. There isn't any built-in mechanism. If your project tests its Jenkins file this way, there's now an explicit list of nice-looking dependency blocks for every plugin that you actually need in order to be able to run this. OK. So we add that dependency, and we run it again, and we get a new error message. This one's also an illegal state exception, but it says there's no pipeline variable mock for SCM from the checkout SCM idiom. What's going on there? Are we just missing another dependency? No. The SCM variable is set up by Jenkins as a convenience to us before it kicks off our pipeline. Here in this unit test, there is no Jenkins. We must do that setup work. So I mentioned that the Jenkins file is a Groovy script. Scripts have a binding, which is a map of names to the values that exist for that script. We can get that binding and set variables in it. So we will play the role of Jenkins and define the SCM variable. For the tests we're writing in this slideshow, it's fine for SCM to be null as long as it exists. But you can imagine that more interesting tests might actually require something interesting there. So we do that. And there are some more dependencies that we have to add for the rest of the pipeline steps that we used in our Jenkins file. But now we have a list of all the plugins our master needs to be able to run our Jenkins file. And with all those dependency blocks added to the POM, we would be able to successfully test one aspect of our Jenkins pipeline. Awesome. So I mentioned source test resources. There's a whole bunch of control handoffs to actually get this test to work locally. The test library is very chatty, but it is instrumented with logging tools and controlled by an XML file. So you can dial the verbosity to what is right for you. Maybe when writing new tests, you want it really chatty. Maybe once you've got your tests figured out, you want it to shut up. That's in Maven, the classic place to put that kind of XML control file is in source test resources. That's why that second block was in test resources. All right, let's write our second test. We are now going to test the which branches go to production or not. Those are the two tests. We don't need to worry about the scaffolding of our test suite anymore. We can just slap 2 new unit tests in there and they'll work. So what's going on here? Well, the setup step, we're once again setting a variable. This time we're setting the branch name to master, because that's something else Jenkins does for us when before kicking off the pipeline. It will, now depending on how you've got it set up, but very frequently the common construction, Jenkins will set branch name to whatever branch it's building. But there's no Jenkins here, so we got to do that. Also, we might want to test other branches. We'll see that in the next test. So we set that we are on the master branch. And then when we run our Jenkins file, we expect that one time the pipeline mock for sh should that. So what's that? That's a lot of things. It is first a predicate passed in to the argument that Spock is looking for. So Spock's going to accept as a match any argument that satisfies that predicate. It is a Groovy convention for when arguments are passed into a closure, you can use it, and Groovy will know what you're talking about. You don't have to explicitly define the inputs to your closure. And the equal tilde is Groovy syntax for regular expression match. Could I have written this much more clearly? Yes, I could, but it would not have all fit on one slide. So what we're actually looking for is sh being called with some argument that matches this kind of SSH attempt to the production application server. And we'll see where that actually comes from in a second. And then the second unit test, where we're testing that we don't attempt to deploy a non-master branch to production, we are setting the branch name to develop, which should not go to production. When we run our Jenkins file, then 0 times should the sh pipeline step be called with an attempt to SSH to the production application server. OK, so where's that SSH to production come from? Here is the deploy function from our example Jenkins file expanded. So we've got the deploy command, which is doing a really rough and dirty Docker compose, try to bounce the application, pull it up to a new version. When asked to deploy to the test environment, we load up some test credentials, and then we SSH to the test application server with that deploy command. When asked to deploy to production, we load up the prod credentials and SSH to the prod server. Pretty simple. So now we're ready to write. Oh, I forgot to mention, that was the end of testing that control flow, those 2 tests. Boom, done. Let's write our third test. For our third test, we've got that deploy function in our Jenkins file. We ought to write some unit tests for that, too, because that's a unit of functionality. We'd like to test that. So let's test that when we ask for a deploy to the test environment, that's what we get. And when we ask for a deploy to the production environment, we get that. So when we Jenkinsfile.deploy, because Jenkinsfile is a Groovy script, and we defined a method in there. And we don't have to run the whole script. We can just call that one method when we're testing it to just see what that one method does. So when the deploy method in our Jenkins file is called asking for the test environment, we expect that one time we load up some test credentials into the SSH agent, and one time we try to do that SSH to the test server, shell out to the SSH command to try to connect to the test server. And the test for testing that asking for production deploy gets you the right thing is exactly like that one, but with the test words swapped out for production. And now we've got 5 unit tests for our application pipeline. So if somebody sends a pull request and they change the Jenkins file, we might be able to catch a regression. Maybe they have added a little true into that go to production for testing. They were pushing their branch out to production. Now this will start failing, and we'll know not to merge that because we've lost our gate. OK. Moving on. Unit testing helper scripts. What if the deploy function got very long and complicated? Or we might want to put it in its own file. Could we still test it? Yes. But more importantly, if you were paying attention, you noticed the test of the control flow, which branch goes to production or not. Our verification was the implementation of the deploy function. That's not exactly what we'd like. We'd like to be able to test something that didn't depend on what was actually in the deploy function. This can get us there, too. So here, we've moved the deploy function into a separate deployer file, and we have a separate unit test case for it as well. And we do need to make one change to POM. We no longer just have a Jenkinsfile Groovy script. We now have some more Groovy scripts, and those need to be available for loading as well. So our deploy function is now in deployer.groovy. It is unchanged, except we return this at the bottom, because that's what you do when you're breaking a script out to a helper script like this. Now our new test suite, deployer spec.groovy, looks more or less exactly the same as before. It's got a different name. We have a deployer instead of a Jenkins file. We are loading deployer.groovy instead of Jenkins file. And instead of Jenkins file.deploy, we are calling deployer.deploy. But other than that, it's exactly the same code. If you've been following along, this is the helper-script folder in the examples folder. We do have to make some changes to our Jenkins file to use the deployer this way, but that's not unique to testing. That's just regular Jenkins usage, so I'm not going to talk about those. They're just here for reference if you get the slides later. Finally, we do have to make some changes to our Jenkinsfile spec, where we're testing our pipeline as a result of this usage, and that introduces us to a new function that we inherit from the Jenkinsfile spec to help us orchestrate unit tests. Explicitly mock pipeline variable. So that deployer, when we're using it in our Jenkins file, is a variable. But it doesn't come from a plugin, and it isn't automatically created by Jenkins. We create it. So we need to explicitly mock it, because there's no automatic way for the framework to know that it's something important. Once we explicitly mock it, we want to make sure that when our pipeline attempts to load the deployer, that we return our mock deployer. You can imagine maybe you don't do that, and you just let the load step be a mock. Depends on what you're trying to test. With that done, these are our branch control flow unit tests for the Jenkins file updated. And you can see now here in our expectation, the only thing that's changed, now we're properly expecting an interaction with a deployer mock just called with the production environment. We're not expecting the implementation of the deploy function anymore, which is a better world to be in. And now we've got the same 5 tests as before, but we have 2 tests testing business logic of how to do something of our pipeline, separate from unit tests of what our pipeline is. That's a good world to be in. OK, so hey, pipeline variables. You know what else has pipeline variables? Shared libraries, right? They have that vars folder where you put your pipeline code. Since this can test pipeline variables, does that mean we can test shared libraries? Yes, it does. If you're not familiar with shared libraries, for large-scale Jenkins installations, of which the community of open-source Jenkins installations is also one, common pieces of pipeline code might be delivered from a different repository than the project. This would let you have a central location defining common parts of many projects' pipelines. You might even put an entire pipeline that way, allowing you to reduce an actual project's Jenkins file to something like that. Just pull in a library, call one step from that library. This is now a very simple and hopefully intuitive, if you've got robust documentation, Jenkins pipeline, but there's no code here anymore. There's not really any code. So the project can no longer be responsible for unit testing any of that pipeline code. It has to rely on the shared library having unit tested its code. So if you're following along, we are now in the shared-library folder of the examples folder. And we have this shared library here, which is going to deliver exactly the same outcome as the previous 2 examples, but through a shared library. So we've got a template now for that message we're going to send to Slack when our application tests fail as a shared library resource. We have a real Groovy file that's going to be compiled as source file that's got some constants that we're going to use to deliver this. And then down here, we have 2 pipeline variables, our deployer, which is going to be basically exactly the same as before, and our default pipeline, which is where we're putting the code that was in our Jenkins file. So Slack message template, simple. The shared library constants only has one thing. It's got that deploy command. Imagine maybe there's some value in separating that out. And the deployer is also exactly the same as before, except it's now inside the call method instead of the deploy method, because it's now no longer some random object that we're creating. Its sole purpose is to be the deployer. You could do other things as well, but it's not the main way that this is done. And the code inside of it is exactly the same, except we're using the shared library constants for our deploy command, which we import up here. Our default pipeline variable is the same Jenkins file as before, except it too is now inside a call, as one does when writing shared library variables. At the bottom, when we're deploying, we're just using deployer with the test and production environments. And then up here, we're using the library resource function to grab that Slack message template text. And then we're being very negligent and using Groovy's evaluate function to detemplatize it instead of using a real template framework, because that fits on 2 lines for slides versus a more robust and defensible solution that would not fit and I would not be able to show you. But those are the only 2 changes we had to make to our Jenkins file that we've been using throughout this presentation to make it work when delivered through a shared library. So what are our tests? Well, so we got to do something else first before we can kick off the tests. We've got that familiar test resources thing. Well, now our Groovy scripts are in the vars folder, so we got to point at that. The resources directory for the shared library also needs to be resources. And we can't use source test resources for the XML file for configuring how chatty the logging is, because the shared library is going to deliver everything in the source directory to Jenkins, and we don't want to deliver our test configuration. So arbitrarily, I picked the test directory. Hopefully that would communicate to somebody seeing that, oh, that's for testing. We also need to update the Gmaven Plus plugin, because now we have Groovy sources to compile, those shared library constants file. Lucky enough, Gmaven Plus has you covered for every step we had before where we were doing something with test sources. There's an equivalent one for not test sources. So add that and it's ready to go. And just as we had to point it at test sources where they were, if we add a block telling Gmaven Plus where our Groovy source is, we're set. They're now recognized as source code, part of the Maven lifecycle, and everything else we try to do with our source will work just fine. In the deployer spec, the test suite for the deployer, we need to make a couple changes, pretty simple ones. The pipeline script that we are loading for tests, when we call that function, the deployer is now in the vars folder, not the root directory. And when we run the unit test, we now just call deployer directly, not deployer.deploy. And that's it. That test suite is ready to go. To do the Jenkinsfile spec to test our default pipeline that we're delivering, we need to make a few changes as well. As before, it's now in the vars folder, so we change load pipeline script for test. And we're now using that library resource pipeline step that we weren't before. So turns out evaluate is not happy to get null as input. So we gotta, for this example, we gotta stub any attempt to load any library resource, because we're using the underscore. We don't actually care what someone tries to load. We're just always going to have it return dummy message, because we're not actually testing anything about the contents of that. But you can imagine you might want to actually put something specific in there. And now, well, that library resource step also comes from a plugin. It comes from the Pipeline Shared Libraries plugin. So we have to add a new dependency block in order for that to be mocked. And that's good. Our POM now communicates to anybody looking at it, hey, in order for this code to work, you've got to have this plugin installed. Kind of silly for that maybe to be in a shared library, because you're not going to be using a shared library without having that plugin installed, but rigor. And the final change we have to make is that global library variables are called, so we expect .call instead of the deploy method we were expecting earlier. So when we're checking the control flow test, does master get deployed to production? Does develop not get deployed to production? When is now just the default pipeline. And then we expect one time the pipeline mock for calling the deployer was called with production. And that's the change that we have to make. This test is ready to go. And now we've got 5 tests for our shared library. 3 tests that our default pipeline does the right thing, and 2 tests that our deployer does the right thing. So now we're able to write unit tests in Groovy with the Spock framework, with automatic mocks for our pipeline step dependencies, but mocks that emerge from a declarative statement of our code's dependencies, the dependency block in the POM. And we didn't have to do anything really funky with the Spock framework. It's more or less just vanilla Spock, less a few special helper methods that I hope read intuitively. And we didn't have to compromise the way we wrote our pipeline code at all. Any pipeline code you can write, it'll work with this. And we can do that not just for pipeline code in our application's Jenkins file, but we can do it with code in our shared libraries as well. So now, this whole notion of pipeline as code, we can start actually having unit tests for it, which I think is pretty cool. That is the end of my presentation. I'm going to leave this slide up. This would be the one to photograph if you're still here. The source code for this is open source on github.com and the HomeAway org, the Jenkins Spock repository. My slides are available at that URL. And in the 14 minutes we have left, I'll be happy to take any questions. Since this does back right up against lunch, if we run out of time, feel free to catch me in the hall outside. I'll make time for you. Questions? Right there in the front.
So, does this work with grapes and the grab annotation?
The question is, does this work with grapes and the grab annotation? I do not believe it will work with the grab annotation, but anything that is Groovy code that can run, the test runner, Spock, will run. So if you make grape and grab available such that it would work in the Groovy code that you've wired up, nothing will stop that from working. Grape and grab are using, is it a grape and grab from a Jenkins plugin, or is it just stock grape and grab?
So contextually, I'm using Spock now for my unit tests and running it through Maven Surefire, and I am using the AWS Java SDK. And I'm pulling that in via grab, and it doesn't work because I guess it's not executed from Maven with the Groovy compiler.
OK. I think that's a little more specific of a question than I can field on the spot up here. But in theory, all Groovy code that is just stock Groovy code will work during your unit test. So if you can get in a vacuum grape and grab working, you can test code with it in there. It will grab the right thing, assuming you've got a network path to get whatever you're trying to grab. Question behind you, third row. Sorry, could you ask that a little bit louder? I can't quite hear. How do you get, the question is, how do you get coverage information? I don't have an answer for that yet. I've been thinking about that, but I haven't written a code solution yet that'll actually give you code coverage report for this. That would be one of the next things that we would want to look at adding to this library. Question over there, yes? OK. First question is, how do you continuously run these tests? Well, in this example, the tests are kicked off by Maven. So whatever your application, if the Jenkins file of your application is the primary thing that kicks stuff off, add sh mvn test to kick off these tests. If you use make to drive your builds, then whenever you've got whatever target you use to kick off your tests, add mvn test to kick these off. The second question, I've already forgotten. Sorry, could you ask it again? Oh, declarative. Second question, does this work with declarative? Out of the box, no, because when you write a declarative pipeline, you're writing data that is fed into the declarative pipeline engine. You're not actually writing code directly. So let me also ask you, how do you unit test a YAML file? Doesn't really make sense. But what you're really looking for, so you kind of need two things for declarative to be able to robustly test your declarative pipeline code. You would need some kind of schema to validate that what you've even written is valid data for the declarative pipeline engine, and then you would need a declarative runner. I have been thinking about that, but haven't looked at the code yet, so I can't guarantee that I could add a declarative runner, but I can't imagine it would be impossible. The validation of your pipeline, is it even valid declarative, might be a little harder, but I'm confident both of those can be solved with code. That's also, along with coverage, the next two big things I think that need to be added to this to cover everybody's use cases. Any other questions? Question right there.
Is there a helper for remotely pulling a Jenkins file from another repo and validating? Say you have your Spock framework set up in a repo, your libraries are held, but you want to validate other Jenkins files.
OK. The question is there support for pulling in Jenkins files, pipeline scripts from other repos to validate them? Yeah, that's the question? Yeah. OK. Well, the world is your oyster. That's something that this library, I think, should not be responsible for. You set up the situation where you've got your code you want to test on hand and the tests you want to run, then you kick off a test run. And maybe you orchestrate that with a Jenkins pipeline. Maybe you orchestrate it with Maven. Maybe you orchestrate it with Ruby or Rake or something. But pull that code in, do it yourself, and you can either use Groovy and grape and grab and kind of things to pull it in at runtime, or you can actually pull the file in. But I think both of those are really up to you to set up. This just handles, once you've got code to test and tests written, have them work. Does that make sense? OK. The questions? Are there any questions in the back that I may have been missing? I've been mostly looking at people in the front where I can see. OK. I saw your hand first, and then you two.
So because this is just vanilla Spock, is it possible to pull in something like Gradle and the Spock plugin and also run DC unit tests?
The question is, since this is just Spock, can I please not use Maven and use Gradle instead? So in theory, I'm sorry, I may be projecting a little bit, but the question was, could we use Gradle or something else that can handle Maven dependencies or that can run Spock? In theory, the answer is yes. You may run into a problem. So the auto-detecting of pipeline steps that exist relies, as far as I know, on the behavior of two different class path scanners when run during a surefire test that's set up a particular way, which is all in the documentation. But I haven't tested how it behaves with other orchestrators. For the use cases here, that actually doesn't matter. But I have an internal use case that I can't talk about yet for which it does. So probably yes. Please, give it a try and let me know. I saw it. He says it works. Awesome. OK. And then I saw your hand next.
Are you familiar with the Jenkins Pipeline unit testing framework? And if you are, what are the differences between yours and that one?
OK. Question is, am I familiar with the Jenkins Pipeline unit testing framework, Jenkins Pipeline unit? Yes. So this arose out of the first problem that I had was I am orchestrating the delivery of pipeline code at my company, and I need to write unit tests for this code that I'm delivering. So I surveyed all the things. Jenkins Pipeline Unit, I was here at their announcement talk last year. Jenkins Jenny, the Jenkinsfile runner, and there's a blog post that's very similar to this, using vanilla Spock, but you have to write your actual business logic as private Groovy classes as opposed in your shared library, as opposed to doing it the normal way. So all of those require some kind of compromise in what they can test, or they require you to write your code a certain way. Since where I am in my company, we set tools and practices recommended to our developers. You can take this off the shelf. It might work for you. We tried this. We know it works. But people also will do their own thing. So we needed a solution that would work with everything and didn't require any compromises on the customer's part. In particular, Jenkins Pipeline Unit is, from last I looked at it, much more about locking changes of your pipeline. You can record what your pipeline should be and ensure that it doesn't deviate. But that's not really a unit test. Unit tests should only test the desired outcomes, the outputs. With Jenkins Pipeline Unit, if I set that up and then I change the implementation of the deploy function, but it still does the right thing, my Jenkins Pipeline Unit test will fail. And to me, that isn't what I was looking for. So that was a pretty long answer. And I saw a hand over here somewhere. Did your question get answered? This general area? OK. Anybody else? The edges in the back? Yes? OK. The question is, outside of unit testing, what other kinds of testing are necessary to increase the confidence of pipeline code that is delivered and used? That's a good question. Technically outside the scope of this talk, I would say the farther right you move from unit testing, the more brittle your tests get, and the less likely their signal is to be useful, and the more work you have to do to keep that signal useful. If possible, all your pipeline code in your enterprise should be rigorously tested with high coverage and good tests, and then your need for any testing beyond that becomes very minimal. And you're not even really testing pipeline code beyond that. You might have integration tests, but now they're testing things like, did the admin wire up the shared library correctly? Did the admin grant correct privileges for this pipeline to run? Is the Jenkins master actually able to receive the GitHub webhook to know to start a build? And that's actually a great situation. You've freed yourself from having to worry about integration and functional tests of your pipeline code. And I think the ability to have richer and more powerful and easier to access unit tests is a way to solve that problem by eliminating the need to create the more brittle tests later on, in my opinion. Anyone else? One more, yes.
Because this is just Groovy, I'm assuming, can you run these tests without a live Jenkins master?
There was, yes, absolutely. There is no live Jenkins master here. And actually, I've got questions that seem to die down. We got 3 minutes left. I can run the tests up here if you want to see that. I think I can. I technically came prepared for that. I'll turn Wi-Fi back on. So here's the repository. We're going to clone it in this conveniently prepared terminal window. So that should work. And we'll go into Jenkins Spock examples, go into the shared library, which is the one everyone wants to see. What does the README tell us to do? It tells us to run make test. Yeah, so it's just Maven. It's firing up the Groovy compile engine, but there's no Jenkins here, which is great, because if there was a Jenkins, you might end up incorporating that dependency into your tests somehow, and you're not unit tests anymore at that point. Question?
Have you done any work related to differences in behavior between CPS and non-CPS code and whitelisting?
Yes. The question is, have I done work regarding the differences between CPS transformed code and non-CPS transformed code and whitelisting? The answer is yes, a ton. I have not encountered any important differences in up to moderately complex pipelines between their behavior under test with this library and their behavior in the world. I am sure that some exist. There's only so much we can do. The hints that the Cloud Bees have been giving about maybe not CPS transforming anymore in a few of their talks here are perhaps a shining beacon towards a future where we don't have to worry about that. Any other questions? I have 1 minute and 40 seconds left. I saw your hand first, sir. The acronym CPS, that is technically also outside the scope of this. It stands for Continuation Passing Style. It's a transformation done to the source code of your pipeline scripts behind the scenes before Jenkins runs it. It's what allows pipelines to be resumed at any point in the execution without losing any data. It's really cool. Look it up and spend maybe a week. It's worth it. There was a question over here. Yes? No. The question was, with CPS, you frequently or occasionally run into serialization exceptions. Does this library catch that? No. There is no serialization happening here. There is no CPS transformation. You will not catch any flaws with your serialization with these unit tests. That is perhaps one case where a live run, the Jenkinsfile runner, might fill in the gaps. But it isn't that hard to avoid. I have a solution, but it is outside the scope of this talk.
Were you successful in using Jenkins test hardness to test the shared library by picking up a headless Jenkins and running it build on
Question was I successful in using Jenkins test harness to bring up a Jenkins on the fly to try running a shared library? No. After doing some plugin development, I had absolutely no interest in ever running a local Jenkins headless on my laptop again. The time it takes, the brittleness, unit tests are what that was the nail in the coffin, that unit tests were what I wanted to write to verify the quality of my code. I am now technically out of time. I'll be happy to stay up here until they kick me off, but lunch ought to be starting out there somewhere.